Some tools are built to last 3 years. Some tools are built to outlive you. And the strange thing is, most people can't tell the difference anymore. What separates a tool from an heirloom? It is not age, it is not price. It is the moment a piece of forged steel outlives the man who bought it and still functions perfectly in his grandson's hand. That moment exists. It happens with specific tools, 7 of them, built in an era when manufacturers did not plan for failure. They planned for permanence. So the question worth asking is this: how many of those 7 do you already own, and how many did you throw away without knowing what you had? This video is brought to you by the Durability Project, where we explore why the things we buy no longer last and the engineering decisions that quietly shape their lifespan. One of these tools is different from the others. It isn't built for force or cutting or gripping anything at all. Yet it might be the most enduring design on this list. Number 1. The hammer that cannot be killed. Most hammers sold today are 3 separate pieces waiting to come apart. That change happened for one reason: manufacturing cost. A steel head pressed onto a fiberglass handle, held together by epoxy and, honestly, a certain amount of hope. That joint is the whole story. Because the moment that joint starts to fail, and it always starts to fail, the head loosens, it wobbles, and what you have is not a tool anymore. It is a liability. Job site crews throw them in the dumpster without a second thought. 2, maybe 3 years of real use, and they are gone. Estwing's one-piece hammer has no joint. Handle and head are one continuous piece of American steel, forged together in Rockford, Illinois since 1923. There is no seam to open, no bond to break, no failure point, because there is no separation to fail. The factory drop forges each hammer by slamming a heated steel billet between 2 dies under several thousand tons of pressure, compressing the grain structure of the metal until it is denser and harder than anything cast or assembled. The leather grip, individual rings stacked and pressed directly onto the steel, absorb shock the way a locomotive buffer absorbs impact. Not comfortable by accident, comfortable by engineering. That single piece of forged steel in your hand carries the weight of a decision made correctly the first time. The hammer solved one problem: remove the joint and the tool stops failing. But plumbers had a different problem entirely. Number 2, the grip that rewrote plumbing. In 1933, George Dearmont looked at the pliers on a working plumber's belt and saw a problem nobody had bothered to solve: fixed jaw width. 1 pipe size, 1 tool, 6 pipe sizes, 6 tools. His answer was the tongue and groove mechanism, a sliding pivot that lets a single pair of pliers span an enormous range of jaw openings without losing grip. He called the company Channel Lock. Tradesmen never looked back, but the real secret lies in the steel. Channel Lock still forges its pliers in Meadville, Pennsylvania, from high-carbon steel, heat-treated hard enough that the jaw teeth bite into pipe without deforming. Cheap imitations exist everywhere. Their teeth round off under real load, and a rounded jaw on a frozen fitting is not a tool anymore. It is just something heavy in your hand. The tongue and groove channel itself is machine tight enough that there is no slop, no rattle, no lateral play under torque. Put a genuine channel lock on a hex fitting and you feel it immediately. The grip is absolute. Because Channel Lock controls its own steel sourcing, its own heat treat, its own inspection, the design has not needed to change since the 1930s. 90 years. Same tool, still the standard on every serious job site in the country. Number 3, the ratchet that carries a lifetime promise. Snap-on does not sell tools at hardware stores. The truck comes to the shop. The mechanic holds the tool in hand, feels the weight of it, and makes a decision. And if anything ever fails, any defect, any breakdown under normal use, Snap-on replaces it. No receipt, no argument. The tool goes back broken and comes back whole. That promise has been in place since 1920. The ratchet mechanism is one of the most punishing components in any hand tool. It transmits torque in one direction and releases freely in the other thousands of times, under loads that can crack a stubborn fastener loose at over 100 foot-pounds. The Powell the small hardened tooth that engages the gear, takes that punishment on every single reversal. In cheap ratchets, the pawl rounds off, the gear skips, and suddenly the tool is not just useless, it is dangerous. In a snap-on ratchet, the pawl and gear are machined from tool steel to tolerances measured in 10,000ths of an inch. Snap-on ratchets run 72 teeth on the gear. That means 5 degrees of arc advances the drive, one full click. In a tight engine bay, 5 degrees is everything. Professional mechanics do not pay snap-on prices for a name stamped on chrome. They pay for that 5-degree arc in a space where nothing else fits. The forever hand tool. Warranty is a contractual obligation, not a slogan. A company cannot sustain unlimited replacements on tools that fail regularly. The warranty works because the tool almost never needs it. Number 4, the blade that never ends. Most modern versions add plastic housing and quick-change sliders. Those parts fail long before the blade does. Most people never question the assumption that a cutting edge wears out. You buy a knife, the blade dulls, you buy another knife. Stanley looked at that cycle in 1936 and rejected it entirely. The blade is not the tool. The blade is a consumable. The tool is the housing, cast zinc alloy, steel blade rail, brass thumb screw, and the housing does not wear out. That brass thumb screw clamps the blade rail with enough friction to hold the edge absolutely rigid under lateral load. No flex, no chatter, no play. Drywall contractors, roofers, flooring installers, they have been trusting that exact mechanism for decades because it does not complicate what does not need to be complicated. The blade locks, it cuts. When it dulls, you advance it or swap it. That is the whole system. The trapezoidal blade format Stanley established became a universal standard. Dozens of manufacturers now make blades that fit the original housing. A box of 50 costs less than a single meal. But the real secret lies in what Stanley did not do after 1936. Every modification added to utility knives since retractable blades, ergonomic grips, quick change mechanisms has been an addition. The core needed nothing added. It was already finished. But here's the strange part. None of these tools are rare. Most of them are still being made today. Number 5, the pliers that wire. America. Klein Tools has been making linesman pliers since 1857. That is not a marketing claim. That date means Klein was forging pliers 25 years before Thomas Edison's Pearl Street station lit up Lower Manhattan. The electricians pulling wire through that first grid were already carrying Klein. The tool existed before the industry it would spend the next century and a half serving. Linesman pliers do 3 things: cut wire, grip wire, twist wire. That sounds simple until you try to build a jaw that does all 3 without compromising any one of them. The cutting edge has to shear copper cleanly. The gripping face has to hold insulated wire without crushing it. The nose has to be shaped exactly right for twisting conductors into a pigtail. Klein has been refining that geometry for over 160 years. The current design is not an approximation, it is an answer. Number 6, the iron giant of the pipe trade. Nearly 3 pounds of ductile iron. That is what a 14-inch rigid pipe wrench puts in your hand. Not steel, not aluminum, not composite. Iron, the same material that goes into engine blocks and bridge components. And that choice is deliberate because ductile iron does something no lighter material can match. It absorbs the hard, sudden shock of torque applied to a frozen fitting without cracking, without deforming, without sending that violence back up into the mechanism. But the real secret lies in the jaw geometry. The teeth on both the hook jaw and the heel jaw are cut at an angle that makes them self-tightening under load. The harder you pull, the deeper they bite. The pipe fights back, and the wrench responds by gripping harder. That self-tightening action traces directly back to Daniel Stilson's 1869 patent. Rigid licensed and refined that geometry. The spring that keeps the hook jaw loaded against the pipe is still there. The fundamental design is still there. Up to this point, every tool on the list was built for force, but the next one was built for something much harder to achieve: accuracy. Number 7. The square that defines accuracy. Before electricity-powered factories and before CNC machines shaped steel automatically, accuracy came down to one thing: the machinist's square. In 1880, Leroy Sterrett built a measuring tool that was not meant to be replaced. The Sterrett combination square was ground, not stamped. Its blade was hardened tool steel. Its head was cast iron machined flat to tolerances tight enough that light itself became the test. Hold the edge against a surface plate, and if you saw daylight, the tool had failed. Most modern measuring tools are stamped from thin steel or molded from plastic. They work well enough until they bend, warp, or drift out of alignment. But a Sterrett square does not drift. Its blade locks into a cast iron head with a hardened steel scriber and spirit level built directly into the body. With care, the tool remains accurate, not for years, but for generations. In many machine shops, the combination square sitting in a drawer today was bought by a machinist who is no longer alive. And the remarkable thing is this: it is still perfectly square. But there is one more tool worth mentioning, one that quietly replaced an entire drawer full of others. In 1907, a Swedish immigrant named Carl Peterson patented an adjustable wrench that could do something remarkable. Instead of carrying a roll of fixed-size spanners, a mechanic could carry a single tool and simply turn a worm gear to fit whatever fastener was in front of him. The crescent wrench was the most famous version, but the principle was what mattered. A movable jaw guided by a precisely cut worm gear, keeping both jaws parallel as the opening changed. If that machine was sloppy, the wrench slipped. If the steel was soft, the jaws spread. But when it was built correctly, the design solved a simple problem with elegant efficiency. One tool replacing many. Tools like these were never meant to be replaced. They were meant to be kept. The real question is not which of these 7 you own. It is which ones you already threw away because they looked old or the grip was worn. Worn is not finished. The difference between a tool and an heirloom isn't age. It's whether someone 50 years from now can still pick it up and use it. Steel does not ask to be remembered. It only asks to be used. This is the Durability Project.